Friends, welcome back. In the last video, we downloaded the entire Food 101 dataset, training data, and testing data, and we see now that there's a lot more food classes here for our model to learn. So this is going to be quite exciting when we eventually deploy it, because people could try it on a lot of different dishes. So let's now move towards, we've got 101,000 images. But to keep things quick as well when we want to keep experimenting, let's now create a subset of the Food 101 dataset for faster experimenting. Now, why create a subset? So we want since we've never trained a model on all of Food 101, we want our first few experiments to run as quick as possible. So we know Food Vision Mini works pretty well, but this is the first time we've upgraded to 101 classes. So we're putting on our machine learning engineer's hat here. We're working for a food vision company. Our prototype works, Food Vision Mini works great. Now we want to step things up a notch. So to do so, let's make, how much should we do? We did 20% for Food Vision Mini, so let's do that the same again here. Let's make a subset of 20% of the data from the Food 101 dataset. Training and test. And in fact, let's make a short-term goal. So let's look up the Food 101 paper. So this is where the dataset originally came from. Food 101, it's a PDF paper. So where was it from? ETH Zurich. So what do we get here? If we look into the results they got, with an average accuracy of 50.76%. So I believe that's not the highest value they got though. They used a CNN. You can read this paper if you like to look at where all of the data set originally came from. They originally used a random forest model, but this paper's about 10 years or so old now at the time of recording. So we want to see if we can introduce some modern techniques to beat the results that they got. And that's in fact one of the best ways to practice machine learning, is to find something that exists in public, a data set, and then use what you've learned to try and beat the results. Here we go. CNN. So when they used a convolutional neural network, their results, they got 56.4% accuracy. So this is our benchmark for deploying our model. We want to beat the original Food 101 paper result of 56.4% accuracy on the test data set. And then see the paper. I'm just going to link this in here. So that's our interim goal. But of course, we'd rather deploy it as well. Beating it is just going to be a bonus. And let's go. We want to beat this result using modern deep learning techniques and only 20% of the data. So that is our challenge. We want to use 1/5 of the data the original paper used and beat their result on the test data set. And we've got a little bit of advantage because we get to use modern deep learning networks and a few other things. So with that being said, I just want to give a quick overview of the data sets we're using / we've used throughout the course. So this is the overall theme. Our motto is experiment, experiment, experiment. So not only with model size, we've been experimenting with data set size. So we kept our experiments small and quick for the majority of the start of the course. Only 225 training images and 75 testing images. Now we're up to section number 9. We're going to create a subset called Food Vision Big 20% data, which is of course a custom split of Food 101 with 101 classes rather than 3. So that's a big upgrade here. And then of course, we're going to go from 450 images to 15,000 or just over training images, and from 150 testing images to just over 5,000. And now my challenge to you is, after we've worked through this problem, to go on and do the extension on your own, train Food Vision Big on all of the data. But let's not get ahead of ourselves. Let's create a sub-split for our notebook. And to do so, we can use Torch has a helpful function. From torch.utils, we have .data and then import random split. And so if we look up torch random split, what does this do? Here we go. At the heart of PyTorch data loading utility is the torch utils. Oh, we don't want that. We want random split. There we go. Randomly split a dataset into non-overlapping new datasets of given lengths. So this is exactly what we want. So if we passed in a dataset here, the dataset to be split, and then two different lengths, so the lengths of splits to be produced, we could do more because this takes a sequence. So let's just say our first split would be 20% of the length of this input dataset. And the second dataset, or the second split, would be the remainder of what's in this. So if this is 20%, the remainder would of course be 80%. And you could extrapolate that out. You could make the first one 10% and the second one 90%. The caveat here is that these both splits together, the lengths must equal the total of this. So if range is 10, 3 plus 7 equals 10. And if ours is 100,000 and the first split is 20,000, the next split must be 80,000, or 20% and 80%. So that's the caveat there. But let's put this into a function, hey, to create some data splits. Random split, and then I'm going to just link to here. Documentation. Beautiful. How can we do this? Maybe we go def split dataset, and of course it's going to take in a dataset which will be of type torchvision.datasets. And then let's go split size. So we'll define what the split size is, will be a float because we want to define it in percentages. And we'll start with a default of 20% or 0.2. And then finally, we'll set up a seed parameter for reproducibility, because if we're going to be randomly splitting our data set, here we go, there's a generator here, which is used for the random permutation, which is what we can do torch manual seed. So we don't necessarily have to set that, but because we've been using manual seed of 42 throughout the whole course, we might as well do it here so that my split is as close as possible to what your split is going to be on your screen. So let's create split lengths to begin with based on the original dataset length. We want length number 1 is going to be equal to an integer, which is the length of the input dataset, which of course for our train data right now with Food 101 is going to be 75,000, and the length of our test data is going to be 25,000. And then if we just multiply this by 0.2, what do we get? There we go. So that's our 20% splits. So we have length data set, and then we want to turn it into an integer. So we're going to feed in here split size. And of course, by default, split size will be 0.2. And then length number 2 can be, let's just go length data set minus length 1. So this is just the remaining length. And because split dataset, or random split, sorry, takes in a sequence here, this could actually be more than 2 lengths, but we only need 2. So you could have 3, you could have 4, you could have 5 if you wanted to create different subsets of your dataset and test your model on those. So let's now print out some info. Print out info. You know how much I love to print out info. Info. There we go. Oh my goodness. My fingers aren't warmed up this morning. Just did the exact same typo 3 times in a row. Splitting dataset of length. Let's go len dataset. So this is the length of the entire dataset into splits of size. The first one is length 1 and length 2. That'll do for that. And then we can go, let's create some random splits here. Create splits with given random seed. And I'm going to go random split number 1, random split number 2 is equal to torch.utils.data.random split. I could just use this above, but I'm just going to type it out for completeness. So we want dataset. So this is going to be the target dataset, of course. We passed it in there. And then we also need our lengths, which is going to be a sequence of the two lengths that we created above. Length 1, length 2, and then if you had length 3, of course, you could pass that in here. Just remember, the caveat is that the total lengths of these values here must equal the overall length of this. So for ours, it works with length 1 and length 2. And then finally, we're going to pass in the generator, which will be torch.manual seed, and then our seed of default 42. Finally, we can return random split 1 and random split 2. Wonderful. So let's test out our function, hey? So I'm going to create training 20% split of Food 101. So we're going to use this function on both the training and the testing data. So train data, I'm going to call this train data Food 101 20%, be a bit verbose here. Because it's going to return a tuple, this returns a tuple of random split 1, random split 2. I'm only interested in random split 1, which is, of course, this is defaults to 20% data split. So I'm only interested in that first one. Of course, this size would change if we manipulated this. So I'm going to set this equal to split dataset, our function, and the dataset is of course going to be train data, and the split size, we don't need to code this in, but we're going to anyway, is 20%. And then I'm going to do the same thing for the testing data. So create testing split Food 101, 20%, test data Food 101, 20%. Equals here. Now, just recall, we're doing this, we're making a smaller data set. We don't necessarily have to. We could test across the whole data set, but that may take a while for our model to fit. We're creating a smaller subset so that we can test our model out to see how it goes on 101 classes before we train on the whole data set. Oh, excuse me. Split data set. That's what our function is actually called. And let's run this. Beautiful, there we go. Okay, so now let's have a look at the length of our data sets. Train data Food 101, just to make sure. So the whole motto here is start small and increase your experiment size when necessary. Beautiful, that is exactly what we wanted. That is in line with what we've said here. Number 9, Food Vision Big 20% data. We have 15,150 training images and 5,050 testing images. That is going to be, or these are going to be our data sets for training our model for Food Vision Big. So with that being said, we've got one more step, don't we? We need to, in the next video, you might want to give this a shot, is turning our Food 101 data sets into data loaders. So we've got data sets, but let's now convert them into data loaders so that we can feed them to our model. So give that a shot, and I'll see you in the next video.